Hi there, this is Math 7. We're on Unit 6 now, looking at Lesson 1 on relationships between quantities. And so we're going to be solving some new kinds of problems in this unit. So here we go. Let's take a first look at the pricing theater popcorn activity. It says that a movie theater sells popcorn in bags of different sizes. The table here shows the volume of popcorn and the price of the bag. So we have volume in this table over here and the price per bag over here. First, we want to complete one column of the table with prices where the popcorn is priced at a constant rate. Okay, so there's a constant rate that allows it to become from here to here, so you can always predict what the cost would be based upon the volume. So that is the amount of popcorn is proportional to the price of the bag. Then complete the other column with realistic example prices where the amount of popcorn and price of the bag are not proportional. So this is our not proportional one, and this is our proportional one over here. So to begin with, we have to take a look at what we're given. It says that a 10-ounce bag of popcorn costs $6, right? And so with that in mind, if I just take a look at this one, if I was to double that, 10 to 20 is double, I would assume that this is proportional, that my cost here would be double that, which is 12. That's a fair assessment there. Now when I get to 35, I recognize that I'm not doubling it anymore, so I need to think about maybe what a smaller unit of measurement would be. So if I knew that 10 ounces is equal to $6, if I was to cut that in half per se, and make that equal to 5 ounces would be equal to $3, right? So I'm cutting that in half. So for every 5 ounces, I increase by $3. In this case here, to go from 20 to 35, that's going to be an increase of 15 ounces. And so if I did 15 times 3, that's going to be, oh sorry, if I did, so 15 ounces. So that's going to be 5, 10, 15. So I'm going up by 5 ounces 3 times. So by doing that, I'm going to increase by $3 for each of those 5s. So at 25 ounces, I would be at 15. At 30 ounces, I would be at 18. And at 35 ounces, I'm going to be at 21. So every time I go up by 5 ounces, I'm adding $3 to the price to keep it proportional. So I'm at 21 right there. Now when I get to 48, 48 isn't a, doesn't go into 5s. It's not a, sorry, it's a little long day. 5 does not go into 48. It's not a factor of 48. So I can't reduce that and work with my 5s and make it look like that. So what I want to do for the 48 one is to set up a simple proportion. We know that our basic proportion is that for every 5 ounces, it costs me $3, right? So let's set that up equal to, here I have 48 ounces, and I want to see how many dollars that's going to be. So just by setting up that proportion there, we could solve and find out what the value or the cost for 48 ounces of popcorn would be if it's proportional. Because this is our constant rate, 5 ounces for $3. That's our constant rate. So when I cross multiply, I end up with 5x equals 48 times 3, and 48 times 3 is 144. So then to get x by itself, I divide by 5, right? Divide both sides by 5, so that x is going to be equal to $28.80. Now that's kind of a strange number there, but that is the proportional price for 48 ounces of popcorn. Now, in the other column, we want to look at some things that are not proportional. And this is what you typically find in a store, right? What you tend to find is that the more you buy, the more you tend to save. So for example, if 10 ounces cost $6 and I got 20 ounces of popcorn, that might not cost $12. Maybe they would say it's a little bit cheaper because you're buying more, and they price that at $10. That's somewhat the idea there. There's no right or wrong, it's just whatever you think it's going to be. Okay, and have a rational explanation for that. When I go to 35, 35 is almost double, but not quite. So if I was to double it from 20 to 40, I would expect it to be at least 20. So maybe I do a little less than 20 because it's not quite double. Maybe I pick a number like 18 because it's a little less than double what it would be. If I take a 48, 48 is almost 5 times what that amount is going to be. So it's going to be less. I could say, well, if it's 5 times that, then a reasonable price is about 30. Well, in this case here, $28. So because I probably want to give a little discount, maybe I would say $25. Again, these are just your realistic example prices for what it could be. Because you're buying more, you're probably paying less than if it was proportional. That's generally true when you go places, all right? Buy the extra large, only costs you 5 cents more. It's not proportional to the volume that you're purchasing. Let's look at the next activity. It's called entrance fees, and we've seen a problem like this before. But in this case here, there is going to be a pattern with a problem, okay? So before it didn't work out that way, this time there's going to be. It says that a state park charges an entrance fee based on the number of people in a vehicle. So the fee is based upon the number of people. A car containing 2 people is charged $14. A car with 4 people is charged $20, and a van with 8 people is charged $32. If we made a little table, we might make something like this. We have people and the cost there, and we know that for 2 people we are charged $14. If I'm looking at 4 people, we are charged $20, and when I have 8 people, we are charged $32. So that's the given information so far. All right. It says, first of all, how much do you think a bus containing 30 people would be charged? So we add 30 to our little table here, and we need to figure out what the cost would be for 30 people. Since this is it's going to have a pattern here, and we kind of set that up from the beginning, what we have to look at is what's happening from one price to the next. When I look at 2 people costing $14, and I look at 4, I'm adding 2 more people here, right? So when I add 2 people, the price is increasing by how much? What's the difference between 20 and 14? We would say it's a difference of $6. So adding 2 people adds $6 to the trip, which means adding 1 person adds half of that, which is $3 to the trip. So every person seems to cost $3 is what it seems to look like based upon that. So if this pattern was to continue here, and I'm already at 8, I'm at $32, all right, and I continue that on, I'm going to need to add an additional, what's the difference between 8 and 30? That's going to be 22 more people, right? So 22 more people times $3 a person is going to be $66. That's quite a lot of money so far. But then I add that to the 32 because I started from there, and we end up with $98 is what it would cost me because I'm adding $3 for each person. And so because I added 22 people, I multiplied that by 3 to find out my additional cost starting from 8. If a bus is charged $122, so now we're going to have the charge here, how many people do you think it contains? That's a great question. When we look at $122, we have to figure out, well, how do we figure that one out? We have to look back a little bit and say, well, let's decide that if we know that every person is costing $3, let's go back to our very first piece of information. If 2 people are going to be cost us $14, we know that it's $3 for one person, $3 for the other person. That's $6 so far. So for these 2 people, it's $6. So how much is the actual cost of the vehicle itself? So the vehicle is what's being charged at the same rate, flat rate, every time. So if I do 14 minus 6, we find out that a vehicle costs $8. So now let's take a look at the $122. If I take 122 and I subtract the $8 vehicle charge for the bus, what I come up with is $114 is the price for people. So now let's take the 114 and divide that by $3 a person. So $3 a person. 3 goes into 11 9 times. We have 2 left over there, and 3 goes into 24 8 times. So it's going to cost us $114. That means that we have 38 people on the bus. So I can add that number right there, 38 people. Now to do that, we actually did create a rule, which is question 3. What rule do you think the state park uses to decide the entrance fee for a vehicle? We were kind of dancing around it with the first 2 questions. So what's the rule? Okay, so the fee is going to be equal to the vehicle, which is $8, plus a $3 per person fee. So every vehicle is going to be automatically $8 and a $3 per person fee. And that's going to be how they determine what the cost will be to enter the park. And that's the idea. Let's take a look at another one. For the next activity, it's called making toast. And it says you have a toaster that has 4 slots for bread. 4 slots for bread. Once the toaster is warmed up, it takes 35 seconds to make 4 slices of toast, 70 seconds to make 8 slices of toast, and 105 seconds to make 10 slices of toast. How long do you think it'll take to make 20 slices? One of the key pieces of information in this problem is that it has 4 slots for bread, meaning that if I have a column here for bread and a column for time to toast that bread, the time for one piece of bread is going to be equal to 35 seconds. Doesn't change. That's true for 2 and 3 and 4. Those are all 35 seconds. Whether I choose to make 1, 2, 3, or 4, it's still that, because I can make 4 at a time. That's why when you get to 70 seconds for 8 slices, that comes down here at 5, 6, 7, 8, because 35 plus 35 is 70. So all of these are going to be 70 seconds right there. Meaning that if I go to 9 and 10 and 11 and 12, I'm going to add an additional 35 seconds, which is 105 seconds, which is what we have here with number 10. So for 10 slices of toast, it's 105 seconds, but the same would be true for 12. So we have a pattern. We're increasing by 35 seconds every time. So every time. So when we look at this question, it says, well, what's it going to take? How long will it take to make 20 slices? We recognize that with 20 slices, I can put 4 pieces of bread in the toaster at a time. So if I put 4 in there, that means it's going to take 5 attempts. I don't know you want to say it there. So you have to do it 5 times. We're going to have to make the bread 5 times and put it in the toaster 5 times in order to get to 20. If I divide that by 4, that's my slots. So knowing it's going to take 5 times, I take the 5 times I put the bread in the toaster, multiply that by the 35 seconds, and that's going to tell me that it takes 175 seconds to make 20 pieces of toast. Does that make sense? So we're looking at 35 for 1 to 4, 70 for that, 105 for 9 to 12, and again if I continued this would be 13, 14, 15, 16, which would be 140, and then 17, 18, 19, 20, which would be 175. That's the pattern that we have in place there. Number 2, if someone makes as many slices of toast as possible in 4 minutes and 40 seconds, how many can they make? Well, 4 minutes, let's break this up into seconds because our rate is by seconds. We know it's 35 seconds to make 4 pieces of toast, all right? That's our rate. So 4 minutes, 60 seconds are in a minute. So in 4 minutes, there are 240 seconds plus the 40 seconds that are here. So we know we have a total of 280 seconds. That's how many seconds we have so far. And because we have 280 seconds, what we want to figure out next is how many pieces of toast we can make in 280 seconds. Well, again, every 35 seconds we can make 4. So let's take 280 and divide 35 into 280. So 35 goes into 280 actually 8 times. 8 times 5 is 40, 8 times 3 is 24, plus 4 is 28. So it tells me that it's going to take 8 cycles, I can get 8 sections of 35. 1, 2, 3, 4, 5, like we did that 5. We can go down 6, 7, 8. So I can be able to make 8 batches of toast. Now, every time I make a batch of toast, I'm making 4 altogether. That's the maximum I can make. So for my 8 times I can do it in 280 seconds, 4 pieces of bread a piece, that means I can make 32 pieces of toast in 208 seconds. 280 seconds. And that's the idea. So it does take a couple steps to get there. For our summary here, the key thing in this unit is that we're going to see situations where relationships between amounts involve more operations. So you're going to see more things there. So we're going to see sometimes, for example, a pizza store might charge the amount shown right here in the table for delivering pizzas. We can see that every time you add a pizza, every pizza or a pie place here, pizza store, they call it pies, So pizza store delivering pies. So oh, whatever. Every time they do this, we're increasing by $10, $10, $10. Well, that is probably the cost for the pizza, right? So an additional pie adds $10 to total cost, but there's already that additional $3 to the cost of what it means. So it probably means is that the pie is going to cost $10 each, but there's also a delivery fee of probably $3 to start the whole thing off with. So that's what we're going to look at there. We have a couple things happening in each equation. All right. So